So this is already the first 4 operators, basically is one slice. So what I see on the right side, you put many different slicing strategies in one workflow.
Yeah, so here what I'm showing is we have also done a thermal simulation on this part. So with the speeds that I've put for this slice, we are going way too fast. And we know that because the material is red across the entire part, and that means it's too hot. So we're printing too quickly. So we can slow that down. So I've just given it different printing speeds here and perform a new thermal simulation. And now it's all green. The first print was about 5-ish hours. The second print, which is now thermally managed, is around 18 hours of printing. So while we get a successful part out, we are dramatically increasing the time that we spend printing. But what I'm showing here is that we can actually put multiple parts in the print bed, whether that's the same part, or you could use another load operator to load a completely different part and slice them. You could give them different slicing settings. And what we're going to do is add more parts, print at the same fast speed as before, so we can thermally manage with more parts and print more for your money, basically. So I mentioned the sequence view before. We've got 2 parts here. We can see from the color coding where blue is the start and red is the end, that we're printing these parts in series. That's not what we want to do. We can use a simple sort operator to sort them both by layer, and then we'll see from the color coding that they will print in parallel, which is exactly what we want. We can go a step further, and we can look at the seams. The seams are here as they were before. When I rotated the other part around, they're in the same relative position, but they're on the opposite side. And that means there's going to be a lot of travel time between the two. But I can reposition our seams. I can update where they are with some coordinates. You can see we have lots of different ways of controlling where our seams are, how they generate. You can do it off features of the geometry, or we can randomize them. But we'll see that by repositioning the seams, they'll be much closer to each other now. So we print one layer of the one on the right and come back on ourselves, and then a small jump here, do the same. So we only have this small jump here now. And our printing time for 2 parts is going to be around 12-ish hours. So it's roughly double the first part that was way too hot, because we're going at faster speeds, but it's still quicker than the single part.
That's very interesting, because now you leave, because you have a second part, you have time for it to cool down as you move to the second, and ultimately you're saving time by making more parts.
Exactly. You're increasing your throughput, you're increasing your yield, and it's very easy, if you don't have this thermal simulation, to not realize you're going to print too fast until it's too late. And then you're wasting time, wasting material. Whereas here you can really optimize, load more parts, and find a good combination of settings that will optimize your whole flow. And here the speeds were changed manually, but I'm going to have a look at this example next, where the speeds are changed automatically. And that's very important in this scenario.